Hello folks. So in this video I'm going to cover how to convert numerical variables into categorical variables using a method called binning or discretization. So I will be covering two types of binning methods in this video. One is equal width binning and another one is equal frequency binning. So let's revisit the diagram which I created. So far I have covered the univariate analysis, categorical variables, where we showed you how to do univariate analysis using count, percent count, or frequency tables. And visually we can create a pie chart, a bar chart, etc. And in case of numerical variables, I covered the box plot and histograms to show you the minimum, mean, median, and mode values, right? And there are separate videos created for kurtosis, skewness, and variance, standard deviation, quartiles, etc. Right? So you can visit those videos. Now, in this video, I'm going to cover this binning method, which is a way to convert numerical variables into categorical variables. And if you want to do vice versa, which is like converting categorical variables into numerical variables, that can be done using a method called encoding or one hot encoding. Okay, and I have already created a separate video for that, so you can visit that video for getting more information around one hot encoding. So let's go back and see how can we do binning or discretization. So, folks, this is Nitin, who is on a mission to democratize artificial intelligence, big data, Hadoop, cloud computing, and blockchain to the entire world. And with this aim, I'm going to create, and in fact, I'm already in the process of creating the associated content and publishing it as well on the periodic basis in order to make it available for the entire community who wants to learn these modern technologies. So you can subscribe to my channel or press the bell icon to keep on getting the latest updates regarding these hottest technologies of 21st century. You can also follow me on Twitter at the link given here. And for your convenience, I have also added subtitles in languages like Hindi, English, and French. So you can enable them as per your needs. Okay. So let me give you an example of binning. That is, how can we actually bin the values for, uh, let us say, if we want to actually bin the values for weight of a person into categories such as 90 to 99. Let me open the spreadsheet here. Okay, so let us say we have weights of a person and we need to create bins for that. So weight can be 50, right? Weight can be 55, 61, 65, 75, 85. In fact, let's say 77, 79. So we can have bins like 52, 59, right? 62, 69, right? And then 72, 79, right? So in this category 50 to 59, we will get two values which are 50 and 55. In 60 to 69, we will get 61, 65, right? So two values again. And in 70 to 79, we will get three values, which is 75, 77, 79, right? So I'm talking about how to create these kind of bins, right? How can we create it? Okay, using these discrete values, right? So basically kind of converting numerical values into categories. So these will be the categories. Category 1 is bin 50 to 59, category 2 is 60 to 69, and category 3 will be 70 to 79. So we are kind of converting numerical variable into categorical variable. So that's why we are creating different categories for these numerical values. Okay, and um, one thing to share with you is that by reducing the non-linearity or noise, binning tends to improve basically the accuracy of predictive models. So if we reduce the non-linearity or noise, binning will tend to improve the accuracy of predictive models which we are going to create. Okay, so binning also helps in identifying the missing values or outliers, right? So in equal width binning, so as I told you earlier, I will be creating explaining two type of binning. One is equal width binning. Okay, so let me explain this equal width binning first. Okay, so in equal width binning, we divide the data into x number of intervals. Okay, let me take a sample here. So let us say I have values. So let us say I have this dummy data. So 0, 6, 10, 12, 16, 18, 20, 22, 30, 32, 36, 44. So let us say I have these 1, 2, 3, 12, 8, 12. So I have these 12 observations or 12 values for which I need to create the bins. Okay, so these are numerical variables, and for these numerical variables I need to create the categories. Okay, I need to convert these numerical variables into categories. Okay, and the one of the method is equal width binning, in which uh, first of all we divide the data into x number of intervals of equal size. Okay, so here we have 12. So if we want to create the intervals, x number of intervals of equal size, let us say I want to create 4 intervals, okay, with 3 observations each. Okay, so 3 observations each. All right, so the number one step is to divide the data into x number of intervals of equal size. So we have created 4 intervals of equal size. Equal size is three observations each, right? And next we basically next step is to uh, uh, basically determine the width of each interval by subtracting the minimum value from maximum value and then dividing it by x, or so here x is equals to 4 because we have 4 intervals here, 1, 2, 3, 4, right? So x is equals to 4, and we want to basically calculate the size or width of each interval. Okay, so the width of each interval is w equals to, and the formula is max minus min divided by x. Okay, so we will create it for each group. Okay, so for this group, first of all the maximum value here is 44, and the minimum value is 0, right? 0. So minimum value is 0. So let me calculate the width. So width is equals to max minus min divided by x, which is 44 minus 0. Okay, and then divided by 4. Correct, because we have the value of x is 4, which is nothing but number of groups or intervals, right? So this will come out as 11. Correct. Now the next step is to find out the interval boundaries, and interval boundaries can be calculated by this formula: min plus w, then next value will be min plus 2 into w, next will be min plus 3 into w, and so on. Okay, so this is the way we create the interval boundaries. So in our example, we have created this. First of all, we created this 4. So number of steps, number one step was this. Then we created the um, width of each interval, which was 11, right? And the third step is to create the boundaries. So here number one boundary would be 0. So using this formula, so min is minimum value is 0 plus width is what, uh, this one, right, 11. So first, uh, so the first boundary is 11. So we can see that our boundaries will be the multiple of 11, right? So 0 plus 2 into 11, 0 plus 3 into 11, and the fourth boundary is 0 plus 4 into 11. So this will come as 11, 22, 33, 44, right? So these are our boundaries, okay, of our bins. Okay, so now next we will create the bins. So number one bin is, so bin is number one here, bin. So number one bin is, let us say 0 to 11. Okay, second bin is 11 to 22. Third bin is 22 to 33. Fourth bin is 33 to 44. Okay, and the value, so if we want to include these values in these bins or categories, okay, I can say categories as well, bins or categories. So I want to assign each of these values into these categories or bins. So in between 0 to 11 we have three values, 0, 6, 10, right? So 0, 6 and 10 will come in this bin or category. In between 11 and 22 I have 12, 16, 18, 20. Okay, so 12, 16, 18, 20. And then in the next one we have 22, 30, 32, and in the fourth one we have 36 and 44, right? Now the question arises, why didn't we include this 22 in this particular bin, right? Because we have 11 to 22 and here we have 22 to 33. So instead of keeping this 22 value in this bin, why did we include it in this particular bin? Okay, because this also has range 11 to 22. Okay, so we kept this 22 value in this bin 22, and the reason for this is, so the square opening bracket, so we can see that we have square opening bracket and closing bracket is parenthesis. So here parenthesis means that this value, parenthesis means that this value is not included in this particular set. Okay, and square bracket means that the square bracket means that the value is going to be included in this particular set. Okay, so in 11 22 set, uh, we have 11, so basically we have this 22 value, but since it has this closing parenthesis, that's why we are not going to include 22 in this particular set, in this set. Rather we are going to include it in this set because this value is getting started from a square bracket. So in 11 22, 11 is included in this bin, but 22 is not included in this bin, and rather it was included in this bin because as a thumb rule, uh, you know uh, parenthesis means that the value is not going to include in this set, but square means that the value is going to included in this set. And in the, so this is all about frequency, this is about equal width binning. Okay, all right, so let me copy paste this. But in equal frequency binning, equal frequency binning, Let's copy paste this again. Okay, so in equal frequency binning, we divide the data into Y groups such that each group should contain approximately same number of observations or values. What I mean to say is, let us say I have 12 values, so I can create, you know, different groups of Y groups. So Y group as in, like, I can create 3 groups for this data. Okay, so 3 groups, three groups, or I could say, okay, so what equal frequency binning means, we divide the data into Y groups. So number 1 group is this, number 2 group is this, and number 3 group is this. So Y groups as in 3 groups. So we divide the data equally into these groups. Okay, these can be 3 3, also the value can be 3. I mean, instead of 3 groups, we could have created 4 groups like this, right? But I just wanted to show you, that's why I just chose 3 groups only. So in equal frequency binning, we divide the data into Y groups such that each group should contain approximately same number of observations. So you can see that each of these group has same number of observation, that is 4. So each of these group has 4 observations. Okay, so uh, if we want to create the bins for these equal frequency binning, we can do so. So in this particular section, let us say the number 1 bin is, so here we will keep bins. So number 1 bin is, let us say we keep the boundary values as 15. Okay, so anything between 0 and 15 will come into this bin. Anything between 15 and 30 will come inside this bin, and any observation in between 30 and 45 will come inside this bin. So if we want to keep these values in these bins, you can see that in between 0 to 15 we have 0, 6, 10 and 12. In between 15 and 30 we have 16, 18, 20 and 22. And in between 30 to 45 we have 30, 32, 36 and 44. And again, 30, we have 30 in this data set as well, in this set as well, and in this set as well. But we are not keeping 30 in this set because 30 is because of this closing parenthesis, right? So as I told you earlier, parenthesis means that this value is not going to be included in this set. Rather, it is going to be included in this set because it is associated with this square opening bracket. So that's why we kept 30 in this set or bin rather than this. Okay, right? So this is the equal frequency binning, where we keep the equal number of observations in each of the group. Okay, so you can create the histograms for the bins created. Okay, so these are the 4 bins, so you can keep them on x-axis, and these are the values associated or observation as associated with these bins. So you can keep the count on y-axis, so 3, 4, 3 and 2. So it has 3 observation, it has 4 observation, 3 observations, 2 observations, right? So you can create the histogram where you can keep the x-axis bins on x-axis and the count on y-axis. Similarly, you can do it same for equal frequency binning, right? So this is a kind of a homework for you. You can create those histogram. Now you know how to create the histogram, so you can try to plot the histogram for these categorical values. Okay, so folks, this is it for this video. To conclude, we discussed about the method called binning, which is a method to convert numerical variables to categorical variables. And I also covered two ways to do this binning or discretization, which were equal width binning and equal frequency binning, right? So here is today's question. Do you prefer to do analysis using statistical method or visualization method? Please share your comments in the comment section given below. I will be glad to hear your views. And if you're watching this video and you're not already a subscriber to our channel, consider clicking on that little subscribe button. And in case you have already subscribed, then click on bell icon to receive the notifications whenever I will release a new video. So thanks for hanging out with us, guys. I will be covering next topic in the upcoming video, so keep on watching. Thank you.